In the next this question 21, all right, we are supposed to find angle theta here, and we know that we have right angles here. Okay, right angles 90 degree is pi over 2 radians. Okay, it's stated in the question. So they are basically saying that these lines AP and BQ are perpendicular to the horizontal TX. Alright, so now how do we find this angle theta here? Okay, right, since this AB they are perpendicular, we can draw a line across. Okay, so we have a right angle triangle here as well. Okay, on top of this trapezium, so it's a rectangle and then a triangle forming a trapezium. Okay, and the height of this triangle, okay, we can calculate 5 minus 3 is 2 cm. Okay, so since this height QB, this length is 3 cm, and we map it across, right, it will be 3 cm. So the balance on top will be height of our triangle for 2 cm. And okay, so in order to find angle theta, we need the value of another side. Okay, either this horizontal, which is equals to AB, or PQ. Okay, but we can't find the horizontal, we can't find the length of AB. We have not enough information at this stage, at this question. But what we can find is PQ. Okay, PR is the radius of this big circle, so radius is 5 cm. And RQ is radius of small circle, which is 3 cm. So the whole stretch add up is 8. Okay, 8 cm. So we have hypotenuse, we have this side adjacent to theta. So we can find our angle theta using cosine. Okay, cosine theta will be 2 over 8. So in order to get theta, we use inverse cosine. Right, 2 over 8 is 1 over 4. So we key into our calculator. Make sure that your calculator is in radian mode. Alright, how to check? If you look at the top of your calculator, there should be a small alphabet R. Okay, if it is a small alphabet D instead of R, you got to go to the mode. Alright, maybe explore around. That you will reach a page where you can change it to radian mode, RAD. Okay, so once you change to radian mode, and then you press your calculator, inverse cosine of 1/4. Alright, you will get, in terms of radian, your answer. Okay, 1.31811. So for angles in radian, we round off our answer to 3 significant figures. Okay. Next, in part 2, we are supposed to find the area of the shaded region. Okay, so the most direct way that I can see how to find is we can find area of trapezium. Okay, PABQ, then subtract by the two sector here, the circle. Okay, however, in order to find the area of trapezium, we need to get the length of AB. Alright, from the first part, we have already been able to calculate the length of PQ, okay, which is 8 cm. Right, and we use a triangle with the height of 2 cm. Okay, so once we find the side using Pythagoras theorem, okay, of this length will be equals to our length AB. Alright, so we use Pythagoras theorem. A square equals to 2 square plus AB square. Okay, because this length in our the base length of our triangle is equals to length AB, so I can write down as AB. So AB, okay, will be 64 minus 4. So we will get square root of 60. Okay, square root of 60. So that's our length of AB. So when we find an area of trapezium, okay, ABQP half times base, okay, times the sum of parallel sides, which is 5 plus 3. Right, this will give us area of, okay, maybe we can leave it like this, right? Okay, because we can later on do a substitution here. 5 plus 3, we can write it as 8. Okay, so if you want to simplify, 8 times half is 4. 4 root 60 will be area of our trapezium. Alright. Okay, and next step. Okay, next step, we can find the area of sector PAR. Okay, area of sector PAR. Right. Because since we have found angle theta, so we make use of area of sector equals to half r square theta. Okay, so theta is angle in radian. So area of sector APR, alright, will be half times 5 square, okay, multiplied by this angle that we have found, 1.31811. Okay, if you want, you can use the exact value to calculate. Alright, so yeah, we can actually leave our answer like this first. So 25 over 2 times 1.31811. Okay, and next we got to find the area of the sector of this smaller circle. Okay, so how do we get the angle RQB? Alright, angle RQB, okay, we can use 100 because this is a trapezium, right? These two sides are parallel. Okay, so this angle theta plus angle RQB will give us 180 degrees. So 180 degrees is pi in terms of radian. So pi minus theta. Okay, so we have got theta equals to 1.31811. So once we do this subtraction, right, we will get angle RQB in terms of radians, which is 1.8. Okay, 1.8234. Alright, so when we find the area of sector RQB, okay, half times radius is 3 square times 1.82347. Okay, so we have got all the areas that we need. Area of trapezium, okay, area of sector of this bigger circle, area of sector of this smaller circle. So in order to find the shaded area now, the last step, we use subtraction. Okay, we subtract. So area, shaded area, okay, 4 root 60 minus 35 over 2 times 1.31811, okay, minus this one, 3 square is 9, so 9 over 2 times 1.82347. Okay, so in answer, your calculator, you should get 6.30. Okay, 6.30. Right, you get 6.3018. Okay, so when you round off to 3SF, it will be 6.30 cm square. Okay, to 3 significant figures. Alright, and I have also realized for part 1, the answer should be 1.32 because I round up. Okay, 8 round up to the next decimal place is 1.32.